With the rise of generative AI, we've also seen how the compute that's necessary for the inference and the training of these models often come with a very large environmental footprint. So this next conversation, titled Conservation or Calamity, will dive deeper into how AI can also be used to reduce some of those environmental costs that it comes with. So for the final session here at the AI stage, please welcome Greg Fallon, the CEO at Geminus AI, and David Walsh, the managing editor at Euronews Next.
Hello and welcome to what is the final straights of Web Summit. We're kind of amazed that there's still people here, and thank you very much for coming to what is the last panel on this stage of this year's event. A warm welcome to you, Greg, as well. Thank you for joining me on stage. I've been looking forward to this panel all week, I have to say, because it's such a knotty, thorny issue with such scope for nuance that I was really keen to get your insights. So let's get stuck straight into it. In terms of AI and discussions of anxieties around AI, I think it's safe to say the discussions have focused on job losses, automation, that kind of thing. Now with such a boom in investment in data centers, the conversation's circling back to the environmental impact. And for instance, COP is happening this week. On day one of COP, AI and the environmental impact of that was on the agenda on the first day. So it begs the question, can we reconcile the possibilities that AI offers for humanity in terms of medical research and things like that? Can we reconcile the possibilities of that with its immense carbon footprint? Is that a naive point of view to think that we can marry the two and that AI could be a solution to the problems it's posing? What do you think?
Yeah, all right, well, thanks, David. And first of all, thank you all for hanging in here at the end of Web Summit. So it's a really good question. I'm sure you all have been hearing the news about AI and power consumption, the announcements recently by Microsoft, Google, and AWS about powering their own data centers. So it is certainly a big issue. I have the opposite point of view, that while it's a big expenditure of electricity, I think AI holds tremendous promise to advance decarbonization and accelerate it. We're going to talk about a few examples here in a moment, but I think that the upside of AI on the climate in particular is a massive opportunity, and especially around acceleration and this whole concept of getting to net zero.
Just a straw poll for the people that are left that have been so kind to come to the panel. How much on a daily basis do you use generative AI or an AI program at work? Just a quick show of hands from the audience. So about half the audience, okay. And then in terms of anxiety about the environmental impact, does that feature into your consciousness at all? So very much the same numbers again, okay. That's interesting. So I'm going to pivot now to your work with Geminus AI. And you co-founded the company 5 years ago. You work with fossil fuel companies, oil and gas companies in the US. How do you, what is entailed in your work? You use physics-informed AI. What is that for the uninitiated in the audience? What does that mean in practice?
Yeah, so first of all, how many people in the audience are familiar with large quantitative models, or at least the term? All right, there's quite a few. So LQMs, it's a pretty simple concept. They're large models that are extremely good at math, and in our case, physics, right? This idea that you can teach AI to have high precision answers for physics. We essentially create these LQMs for engineering applications, right? Specifically mechanical engineering applications where you're trying to optimize large machines. In our case, large machines that take a lot of energy to operate and sometimes emit quite a bit of carbon emissions. And we work with our customers to reduce carbon emissions, and the customers get the double benefit of increasing the productivity of the machines. So our work usually makes the machines more productive, but it also significantly reduces the carbon footprint.
So we're talking about optimizing machines. Let's talk about brass tacks and what issues it might solve in terms of the use of raw minerals or energy consumption, water consumption. Let's take water for a case study because it's probably one of the most pressing and most scarce resources that are being used in AI, for example, cooling data centers. The UN has said 2/3 of the world's population are facing water scarcity and drought, at least 1 month every year, and that's getting worse. So in terms of water consumption, optimizing that to make it more efficient, how does Geminus AI play into that as a case study?
Thanks, David. This is one of my favorite examples. So when you look at distribution of water, let's say the water that comes out of your tap in your hotel, that system involves a lot of pipes to deliver the water, a lot of valves to direct the water, and pumps to move the water. Those pumps consume a ton of electricity. And if you look globally at statistics, pumps alone consume about 10% of the world's electricity, like moving fluids and sometimes gases. That's a tremendous amount, and it turns out that in most industrial applications, the way pumps are used is they're kind of turned on high, so they're consuming the most electricity they can, and then someone uses a valve downstream to adjust how much flow comes out, right? And that's an incredibly inefficient way to do things, especially when the price is so high. And so what we do is work with water distribution companies to figure out a way to create an AI model that understands how their water distribution works and will make recommendations based on current water demand, what the pump settings should be, right? So the AI model is looking at what happens, someone's taking a shower, someone else is using their tap to create hot water, and what does the pumping situation need to be for the central authority? So we've done that in a bunch of benchmarks. In some cases, we're able to cut energy consumption by up to 40%. So it's a massive
staggering,
impact.
yeah. Mm-hmm. So I think with a lot of potential solutions, there are solutions or technologies that are making real impacts and having real results. But the problem is often how to scale it up, how to make that technology more widely available. So to use Geminus AI as an example, you're currently working at about 3% production of US oil and gas in the US oil and gas sector. That's expected to grow by next year by, I think I read 15%. But deployment is still relatively low, and it's US centric, I think I'm right in saying. So how do we overcome obstacles of scale? What are the main obstacles to scaling up, and how do we solve those to make sure that, your company and your technology is having a wider impact?
Yeah, for sure. So there's a couple challenges here, right? So the first challenge in scale up is the technological challenge. So the types of models that we create have to be very high precision models, right? Engineers are using them, they're controlling large systems that could be unsafe if they're not controlled properly, so the precision is critical. And so getting to that precision requires a lot of special algorithms to ensure the proper training. Getting that right is one thing. The other thing that you have to deal with in an industrial setting is some of the machines are very old. They don't have a lot of data, right? So what do you do with a machine that has 4 sensors, but it's a massive system? So you have to deal with that particular problem. And so there's an algorithmic approach that we've taken. We've come out of academia. I've been working on this for about 12 years. And our algorithms happen to be very data efficient and very precise, right? So that's helpful. The other nice thing about the special approaches we're bringing to the marketplace is that the time to create the models is very short, right? So when we work with customers, if they can create a high precision AI model, it's usually taking them about 12 to 24 months with a huge staff of PhDs, right? Which is not at all scalable, right? There are tens of thousands, hundreds of thousands of water systems around the world, oil refineries, power plants. So compressing that time is absolutely critical, and that's something that we've spent a lot of time doing. So we can often get a deployment done in under a month, sometimes a few weeks, which is critical. So there's the technological piece of scaling that's a big deal, right? And so that's part that is solved. The other part of the problem is the culture and processes within these large industrial companies. Anybody who's friends with a mechanical engineer, I'm one of them, or a chemical engineer, knows that they tend to be conservative in their decision making, and they're conservative for a good reason. And industrial processes are very strict to make sure that things don't blow up and things go correctly. So how do you work with engineers to convince them that these tools can deliver the high precision and the scaling that they need within these machines? That's a different challenge, and that's a go-to-market challenge. The approach that we're taking is teaming up with, within each vertical, with companies that are extremely well known and have the expertise and can bring us to market. So, for example, in the energy sector, we're partnered with SLB. They used to be called Schlumberger. They're one of the leaders in the energy sector, and they bring us both expertise, they embed us in their tool sets, and they talk to their customers. So the idea of adapting to those particular engineering problems is native. We're working on partnerships in utilities, partnerships in chemicals, so on.
Okay, so that's obviously one approach, and we're talking about industrial practices and optimization of machines and things like that. Again, one approach, but then you have big tech companies, for example, recently, you alluded to it in the kind of first answer about Microsoft restarting the 3 Mile Island nuclear power station. You have Google and Amazon reaching deals to bring in energy from mini reactors. So to pivot slightly, I mean, in terms of combating carbon footprints, you have your approach of optimization. Is this opposing, or not opposing, but a different approach? Is that it's effectively like taking a sledgehammer to crack open a nut, really, isn't it? So do you have any thoughts on their approach compared to maybe a company like yours?
So their approach to AI and the building of their data centers?
Yeah.
Yeah, so just to back up, right, the large hyperscalers announced partnerships with several nuclear companies to provide electricity to their data centers, and they're going to build the data centers right next to the power generation facilities as a way of minimizing their impact on the electrical grid, right? And so I think you could look at that in two ways. One, you could look at and say, hey, listen, they're consuming all this electricity, they're taking away sources that could be delivering power to the grid to fund, to power other things. Or you could look at this and say, hey, these guys are selling a product, AI, they're generating revenue, and they're using that money to pay for renewable sources that are going to power their data centers. And by the way, they're going to protect the overall grid by powering their own data centers and not affecting the grid in general. I think it's a really good solution. I think it's very important for two reasons. One is they're protecting the overall grid, which needs a lot of help to begin with. If you've kind of studied the projected use of electricity over the next 10 or 15 years, it's massive. And that projected growth in electricity consumption has nothing to do, or very little to do, with the data centers and AI. It has a lot to do with electrification of society, right? And so there's a massive demand. The grid is going to have to double in size in the next 25 years. So it's good that they're protecting the grid. I think the other thing that is exciting is you now have this revival of the nuclear industry, which, for better or for worse, is another way of generating at least carbon-free electricity. And I think without this type of injection, you have a very stagnant industry that could have a huge impact on the world. You've got these SMRs, these small modular reactors that can be used in different sites and industrial facilities. And having the hyperscalers go first, adopt these types of technologies, I think is a really good thing, because it'll introduce them to market, hopefully prove them out so that we can use them at scale as another carbon-free energy source.
just going to pick up on a point you made about demand on national grids, because as you alluded to, demand is going to soar in the next decade. I read a statistic in the IEA report from last month that said the equivalent of a country like Japan, the demand is going to be the same every year for the next decade, which is higher than forecasts from last year. So that's going to hamper cutting carbon emissions. And amongst all that, AI is actually only a small part of that energy consumption. So is now the opportunity, is it the golden opportunity for AI to prove itself, to be more of a, to prove itself as more of a benefit than a negative? Would you agree with that assessment?
I would fully agree with the assessment, right? I mean, so there's no question that AI is consuming a lot of electricity. As it grows, it'll consume more, right? But as David just said, if you compare it to the overall global consumption of electricity, it's a very small slice. And I think now is the time for artificial intelligence to prove itself with its impact on society, right? So we're trying to reduce carbon impact and decarbonize industry, right? And if you look at the studies out there, decarbonizing industry through AI has the potential to reduce greenhouse gas emissions by 10% by 2030, right? Which is a really meaningful amount if you look at the carbon curve overall. I think the impact on health, the impact on just optimization of transportation will have an impact on climate. There's an upside to a lot of what we're doing, and I think making the right investments and getting in these types of artificial intelligence technologies that are benefiting humanity is critical.
We're running out of time, so I want to give you an opportunity to maybe offer some takeaways for the panel audience to go home with in terms of how AI is going to speed up climate action. What are the big takeaways that everyone should go home with from your perspective? Well, just to put you on the spot, you've got 2 minutes.
Yeah, to put me on the spot. So, I think that the big takeaway for this audience is that, I'm not talking about science fiction. The technology exists today to drive electrical efficiency in industry, which includes the appliances that you use in your house, like air conditioners, and making them more efficient. So I think that it's possible. It's possible today, and I'd like to make sure that we all are aware of that and can do whatever we can to put pressure on government agencies, on companies to try to drive efficiency. I mean, there's regulatory opportunities, there are market opportunities to do business with companies that are driving efficiency.
Corporate responsibilities?
Corporate responsibilities as well, yeah.
So we're approaching the end of the panel. I want to thank everyone for staying with us. I appreciate it's the last discussion on this stage, but I hope you've had a successful Web Summit. I hope to see you next year, and safe travels back to your homes, wherever that might be. Thank you very much for staying with us. Thank you.
Thank you. Thank you, David.
All right. Thank you so much, everyone, for coming. That's all we had for you today, or at this whole Web Summit event, at the AI Summit stage. I just wanted to say that I hope you had an amazing event, and enjoy the rest of your time in Lisbon. Thank you.